Today we talk about functions a little bit more. Okay, we remind ourselves of a test to determine if something is a function, simply called the vertical line test. If you take a vertical line and drag it across any part of the function, if it ever passes the function more than one spot, then it is not a function. Does this one pass the vertical line test? Yes. Suppose I had a horizontal line. Would it pass the horizontal line test? No. We won't talk about a horizontal line test and what that means right now. Okay? So this is a function. Yes. Drag this way. Okay? And no, fails right there, doesn't it? A vertical line itself is not a function. So when you get to a vertical line drawn like that, we would say no. Next one? No. How about the last one? Yeah, it is. You see, this green line is a vertical asymptote. It's not part of the graph, so it only crosses once after that. Now, this can be somewhat deceiving. You might say, well, it looks like it goes straight vertical there. If it's approaching a vertical line, then it's never quite completely vertical. Okay, it gets really close, but not quite. Okay. All right, another way that we can determine if something's a function is we can solve for y. So in this example, we subtract 2x squared. We get negative 4y is equal to negative 2x squared plus 8. Divide by negative 4, we get y is equal to 1/2 x squared minus 2. First of all, you know what kind of shape that makes. What shape does it make? Is a parabola function. Yes, it is. Now, second of all, you can look at it from an algebraic structure. If you plug in something for x, you will get one output for y. Remember, the definition of a function is a relation in which every element of the domain corresponds to exactly one element of the range. So if you would plug in something for x and come out with 2 values or 3 values or 4 values, that would be different. But you don't. You come out with one value. Whereas in this one, if we subtract x squared, you get y squared is equal to 9 minus x squared. And we square root both sides. Notice when you take the square root of 8y squared, you must list both the positive and the negative solutions. So what that means is if you plug in something for x, suppose you plug in 0, 9 minus 0 is 9. The square root of 9 is 3. But this says you're going to list positive 3 and negative 3. So what that means is if I plug in 0, I get out 2 values. I get 3 and negative 3. Well, that defies what it means to be a function, right? An input of 0 gives us 2 outputs. Okay? Now, here's another way you can think about it. What shape does that make if you were to graph it? Oh, I've failed you. This is your last test. So does the C, rhymes with Urkel. Very good. It's a circle. What's the center? 0, 0. What's the radius? 3. Is a circle a function? No, it does not pass the vertical line test. So you can think about the graph in that way. I would request a new math teacher. Let's subtract x from both sides and subtract 3 from both sides. We get negative y cubed equals negative x minus 3. Divide by negative 1. Y cubed is x plus 3. How do I solve for y? Cube root. And when we cube root something, we only come out with one result. For example, what's the cubed root of 8? 2. You don't list negative 2 as well, right? So in this situation, we just have one solution. So yes, this is a function. Yes, that's a function. Whereas the middle one is not. Now, I'm not going to make this really complicated for you guys, but I would hope that on the ACT, that if they ask, is x squared plus y squared equals 9 a function, and they don't give you a graph, you would be able to do one of two things. You'd either be able to say, oh, it's got a y squared, so it most likely isn't because we get two solutions. Or you could say, it looks like a circle, and that's not a function. Okay? That's basically what I want you to be able to understand from there. We good? Let's get to the last part for today. I don't know how to make this any more clear than saying this. If you do not learn how to graph these piecewise functions before the test, you will not be able to get an A on the test. You will automatically drop yourself at least one letter grade. Okay? This is extremely important to your understanding domain, range, as well as the graphs of different functions. So, if you are all getting lost during this time, or if you're getting drowsy, somehow you gotta slap yourself, wake up, and lean into it. This you have to figure out, okay? Am I clear? Let's do it. Do not write what I'm gonna draw. Do not write it down right away, okay? We're gonna kind of gently get into it. People used to ask me, how do you graph piecewise functions? Like, well, you know, you just kind of think about it. Well, that didn't help out too many kids. So I had to think about, well, how would I teach it? I don't know. I've come up with, I think, is a good way. This is really two functions, y equals 3 and y equals x minus 4. It says that the function is 3 for x values less than 2, and it says that the function is x minus 4 for x values greater than or equal to 2. Well, if I look at those two graphs, I have y equals 3, okay? And I have y equals x minus 4, which is a line that goes through negative 4 on the y-axis and has a slope of 1. Those are the two graphs, right? Now, is that a function? No. Why? It doesn't pass the vertical line test. We got to get rid of certain parts of this. For example, if you look at it, it says it wants to look like the graph of 3, but only until you get to an x value of 2. So if I take my eraser, I want to erase all the parts where x is greater than 2. So I erase all that, and finally I stop right there, because that's where I get an x value of 2. Now, do you think I'll have an open circle or closed circle there? Open. And then I look at my other graph, still not a function. I look at my other graph, and it says, well, I want to be x minus 4, but only for values greater than 2. So I have to get rid of everything where it would be an x value less than 2. So I get rid of all this stuff, and you think I'll have an open or closed circle there. Closed circle there. Is this now a function? Yes, it is. It passes the vertical line test. So my ability to erase with a smartboard is easier than your ability to erase with a pencil. Now, some people like the erasing method, and that's fine. I just teach what I think is the most efficient way for the class to do it. If you want to do that way, fine. Here's the way I generally teach kids how to do it, okay? Number one, I say, get that picture in your mind. Everybody got that picture in their mind that they're supposed to look like those two things? You got to be able to look at 3 and know it's a horizontal line. If you don't know that, then that's something we've got to figure out. That was last unit, and that was 9th grade. You got to be able to look at x minus 4 and say it's a line that goes through negative 4 and a slope of 1. If you can't do that, you're going to have to come and see me. We got to talk, because, again, that's review. Once you got those two shapes in mind, what we want to do is we want to come up with the endpoints, okay? So I'm going to come up with the endpoints right here. And what I do is I know the endpoint happens at an x value of 2. When I plug in 2, what's the output value? 3, okay? And will it be an open or closed circle? Open circle. And it says it wants to be that graph for x values less than 2. So I draw that. Then I go to my next one. And again, the disruption in the graph happens at a value of 2. So I plug in 2 here. And what do you get? Negative 2. Open or closed circle. And now I continue this graph. It has a slope of 1 okay? And I'm going to draw it with a slope of 1, and I get that. And that's the graph that I want. Thank you. Excellent question. What that means is all the values between 2 and negative 2. I'm talking about a coordinate, an x, y value, not an interval. So this is just a coordinate. We don't ever use brackets with a coordinate. Only brackets with intervals, okay? Now, if we wanted to express the interval of this part, it would be from negative infinity to positive 2 with a parenthesis, and then for this part, it would be bracket 2 to infinity, okay? That would be the set of domain for each one. But I'm just showing what the coordinate is that I plot. Does that help? Olivia, you had a question? I take 2 and I plug it in there. 2 minus 4 is my negative 2. Now, there's 2 problems that people had in other classes with this example. One problem they had, they said, well, Mr. Gens, you can't really plug 2 in there because it doesn't say it could be equal to 2. Well, I took care of that with the open circle, okay? You're right. F of 2, if I actually plug 2 into this function, what is the output? Negative 2. That's the output, okay? But in order to generate the circle, I can still plug that in. The other issue that people have is they're like, well, Mr. Gens, I know that that goes through negative 4. You didn't draw it through negative 4. Well, I can't draw it through negative 4 because the point 0, negative 4 isn't part of this one because that has an x value of 0, and I need x values that are greater than 2. So that does not work. I don't show that part of the graph, okay? I just show that portion. Second example should become a little bit more clear for you. What does the first graph look like? X plus 3. A line that goes through 3, slope of 1. Is that in your mind? What does the second graph look like? Centered at 0, 0, right? I've got those in my mind. That's what I want to think about. So now, let's actually consider the endpoints. Where does the disruption happen? What x value does the disruption happen at? So I'm going to plug negative 1 into x plus 3. What do you get? 2. Open or close circle at negative 1, 2. Closed. Now I will draw it with a slope of 1. And I have to draw it down this way because we're going for x values that are less than negative 1. Now I plug in negative 1 here. Negative 1 squared is open or close circle. Open. And you remember that parabola, we're not going to draw the left side of it. We're going to pick up with it as it comes to 0 and then goes up. And that's my graph of that piecewise function. Very good. It states that it's a function. That is all function notation. So therefore, they must all pass the vertical line test. If they don't pass the vertical line test, then you did something wrong. And that's a great question, Grace, because I do get students who they'll get to the test and they'll draw graphs that look like this. They'll draw that, and then they'll draw that, and then they'll draw whatever, and I'm like, well, that doesn't pass the vertical line test. That fails many times. So, and you may say, well, I was confused. I didn't know what to do. I get it, but at least you know you were wrong, right? It must pass the vertical line test because they are functions by definition, function notation. Okay, this one is different because there's 3 of them, okay? And so it's no big deal. I'll show you how to take care of it. So again, you don't have to draw this, but this is just what's trying to pop up in my brain. 4 minus x squared. What does that look like? Parabola, it's upside down. Okay. If we found the x and y intercepts, the x-intercepts would be 2 and -2. The y would be 4. Okay. But upside down parabola. What does the graph of -2 look like? In my early days of teaching, I used to say a straight line, but all lines are straight. So it's a horizontal line. Gigi's laughing. Thank you. Brought some joy to my life. All right. X minus 5, another line, right? Slope of 1. There we have it. So those are the 3 graphs that I have to keep in mind as I sketch this piecewise function. Okay? So what do I plug in? 1. And what do you get? 3. Open or close circle? Now you remember from our sketch, it went up to 4 and then back down, like so. In fact, it went through -2. Well, I'm done with the top one. Let's go to the middle one. What x value do I plug in? 1. That's where the break happens, at 1. You plug in 1 and you get -2. Open or closed circle? Open circle. For the middle one, you can see I have to plug in 2 x values because it breaks at -1 and then it breaks at 1 and then it breaks at 3. Yeah, it breaks again at 3. If I plug 3 in, what do you get? -2. Open or closed circle. And we remember what that graph looked like. That was just a horizontal line. And then I have my last one. What do I plug in? 3. And 3 minus 5 is? Open or closed circle? Open. Oh, that one's already open for me. Just picks right up there, but there's no circle filled in. Okay. And a slope of 1. So I head on up like that. Excellent point. Okay. So my good friend Jessica is doing some work, and she was able to sketch a graph without really plugging the stuff in. She just thought about it, right? I would give you 3 out of 3 points on the test for that. Now, here's where showing your work really comes in for help, okay? Number 1, if you have something incorrect, then I'm wondering where that came from. So if you show your work, I can say, oh, I think that they just, subtracted incorrectly or they missed a negative or something. So in trying to give you partial credit, that helps. Here's how I grade this problem on the test. I'd give you a point for having the open and closed circles correct and at the right placement. So I don't just want to see that this is an open circle. I want to see it's at 1, 3. You see that? Now she had it at 1, 3. Second of all, I want to make sure you have this graph of this parabola. And I want to make sure that you have this graph of this horizontal line and then the graph of the line with a slope of 1. So those are the things I'm really checking. No, I don't care about that. I'm just making sure you guys know that this does, what? I'm not going to, but I am going to make sure this, I do want to see this head back up towards negative or towards +4. I don't want to see this. And this is sometimes what people will do. I don't want to see that. And I don't want to see that. Because it definitely has that little turn there. I'd like to see that. Okay. So there you have it. Any other questions regarding that? Oh, the function test. Does it pass the function test? Forget about the blue stuff. Look at the green. Okay. Now, if I ask you this question, what is f of 0? What would you tell me? It's 4. You plug in 0, you get 4. What if I said, what is f of 1? It's undefined. Yeah, there's no value for that. Okay, 1 is not part of the domain. Yep. There's no. Whoop. you look at 1, there's no defined function value for that. What if I said, what is f of 2? Negative 2. What if I said, what is f of 3? Undefined. There's no value there. So you don't have to have a closed circle for every spot either. Okay, you can have open spots. All right, so some of these problems are piecewise functions. You're going to want to make sure you really focus on those and try to do an excellent job with them. You may need to come in before school or after school to ask for some help on it. But without a doubt, this is a crucial part of your next test. Your next test will not be until after your final exam, okay? Speaking of your final exam, I have your final exam study guide, and it will be on Tuesday of next week.